Okay, so we're going to start with the tangent chord, tangent secant. Take a look at this picture that we're giving you. You will notice it is pretty similar to what we talked about with our inscribed angles. And when I say it's similar, the thing that is the same is the fact that our vertex is on the circle. So that's the first thing I want you to recognize or write down at the top is for this one, the vertex is on the circle. And just like with our inscribed angles, when the vertex is on the circle, we say that the angle is equal to 1/2 of the intercepted arc. So when I'm looking at this picture, again, B is my vertex, angle ABC would be my angle, the intercepted arc would be arc AB. So if I told you that the arc AB is 100, what would be the measure of angle ABC based on what I just told you? It would be 50. So this angle here would be 50 degrees. So if I'm writing that out up here above, angle ABC would be equal to 1/2 the measure of arc AB. Again, we can also look at the angle on the left. If I told you that the major arc AB, let's say, is 260, then we could also identify that angle B on the left side would be 130 degrees, just 1/2 of that 260. So again, it's a tangent. In this case, it's a tangent chord. It could also be a situation where it's a tangent and a secant. If AB would have gone all the way through the circle, you're still going to get the same angle measurements based on the intercepted arcs. Okay, so our next angle relationship, we're calling this a chord-chord. So notice in this particular picture, the two chords are going to intersect inside the circle. So you might want to write here at the top, vertex inside the circle. Now, the other thing I want you to notice is not only is the vertex inside the circle, but the vertex is not at the center. So I don't know if you want to put in parentheses, not at the center, you could do that. Because remember, when the vertex is at the center, we call that a central angle. And the central angle, we know that the intercepted arc, that those are the same. And that's not the case here. So I'm going to utilize angle 2 as my example for this one. You should notice that angle 2 intercepts arc BC. The other side of angle 2, it intercepts arc AD. So when the vertex is inside, we actually have two intercepted arcs. So our formula for this is, we would say angle 2 is equal to 1/2 the sum of the two intercepted arcs. So we're going to add together the two arcs. In this case, the arcs would be BC and AD. So 1/2 arc BC plus AD is going to be the angle measure. So if I told you in this picture that BC is 30 degrees, arc BC, and arc AD is 130 degrees, to find the angle measure for angle 2, we're going to say 1/2 of 30 plus 130. And when I add those together, 30 plus 130 would be 160. Half of 160 would make that angle 2 equal to 80 degrees. So angle 2 is 80. And this angle on the other side, which is vertical to that, is also 80. So with the tangent, tangent, tangent secant, and secant, secant, probably somewhere at the top you're going to want to write vertex outside the circle. Now, just like with the last one we did, there are going to be 2 intercepted arcs here. So if I'm focusing, I'm just going to focus on this top picture, angle C. So for angle C, it intercepts arc AB, which I'm going to tell you in this one, we're going to say arc AB is 160. And then it also intercepts this big arc, which is on the other side of that, which we're going to say is 200. Now my formula when the vertex is outside is I'm going to take 1/2 of the bigger arc minus the smaller arc. So in this picture, if we're labeling that, angle C would be equal to 1/2 the measure of arc ADB minus the measure of arc AB. And if I fill in those values, 1/2 of 200 minus 160. Well, 200 minus 160 is 40, and half of 40 is 20. So we would say in this picture that angle C is 20 degrees. Now that first one we did was a tangent, tangent. The rules are the same for a tangent and a secant, or a secant and a secant. So I'm not going to rewrite the rules on here because I know we don't have a lot of room, but I am going to fill in some numbers here for us just to kind of go through that process. So AB, let's say, is 170 in picture 2, and AD is 80. So if we were to solve for angle C in picture 2, I would do 170 minus 80, which is 90, and then half of 90 would be 45 degrees. Again, same is true with the secant, secant. Again, I'm going to have 2 intercepted arcs. I think the intercepted arcs are a little easier to see in the secant, secant. If I told you in this one AB is 90 and CD is 60, again, we're doing half of the difference. So 90 minus 60 is 30, and half of 30 would be 15. So let's just do a quick summary of our whole spinner here. So we've got situation when the vertex is outside the circle. So that's half the difference. We have our situation when the vertex is inside the circle but not at the center. That's half the sum. We have our tangent chord or tangent secant where the vertex is on the circle. And it is the same rule as our inscribed angle, which the vertex is on the circle. So it's just half. And then our last one, the central angle. Remember we talked about on the central angle, they're the same. So if the central arc is 60, then the central angle is 60. Okay, so central angle vertex is at the center of the circle.